project that we've been working on at BitPay called Foxtrot. There are a lot of things that we work on at BitPay that are not that visible outside of the company. Things that we're working on that we're not quite ready to release. And I'm very hesitant to release things before you can actually download the code and start working with it. But I felt like this was a good one to talk about. Tarek said it needed to be technical, and this is one of the projects that I've been working on personally. So I figured I would know about this project more than I would know about some of the other projects going on. As I'm going through this, please stop me and ask questions. It actually makes my job a lot easier if you do that. So I just enjoy to get questions during the presentation, so don't hesitate to raise your hand. If you have a question about something I say and want clarification, then just let me know. All right, Foxtrot. So I put it up on GitHub this morning. It's at github.com/bitpay/Foxtrot. And what this is a decentralized routing network based on elliptic curve cryptography, the same cryptography obviously used in Bitcoin. The endpoints in this routing network are specified by public keys, so you can see a key pair. The routing decisions are in the nodes on this network are based on observing what your peers are doing. So it's a peer-to-peer network, and you're kind of observing how well your peers are performing and making routing decisions based on that. The peer-to-peer links are encrypted, and so are the independent or the end-to-end connections that you make over the peer-to-peer network. So actually, it's two layers of encryption, one end-to-end, and then for each of the peer links, those are also encrypted. The reason I wanted to encrypt the individual links is I felt like you could potentially do traffic analysis. If you're a router on the internet and you've got one endpoint here that's participating on the Foxtrot network, and you have data coming in and data going back out that's being routed through that endpoint, then traffic analysis, if you don't encrypt that, then you can just see that the same data is going in as coming out, and you can rule out that node as being a destination for that traffic. This is designed to run on layer 2. You're familiar with the OSI model, so I didn't use anything like distributed hash tables because I felt like I really wanted this to run, right on top of Ethernet at some point in the future. So, it's actually designed to run to do routing on direct, at the link layer. So this could conceivably run in parallel to TCP/IP. We have plans to incorporate Bitcoin for bandwidth billing, but that's not implemented yet. We built all this on top of Node.js, and we designed it to be protocol compatible with the net module, if you're familiar with how you create sockets or interface with the socket layer in Node.js. So you can very easily swap out a Foxtrot connection in place of a regular socket connection. And then the last point, it barely works. It's brand new, so we're working on solving all the issues to make it work with Insight right now. And just as of a couple of days ago, we got it working with Insight and getting two co-payers to be able to use two different Insight nodes to then coordinate a multi-signature payment proposal. All right, so that gets a little bit into this slide, which is the motivations. So CoPay started out doing browser-to-browser peer-to-peer communications using WebRTC. But we realized pretty quickly that that wasn't going to work on mobile browsers, and the browser support there is very spotty for WebRTC. And the other issue we had is all the co-payers had to be online at the same time to have a transaction proposal and to create a multi-signature transaction. So we wanted to make that asynchronous and make it so you can use CoPay from any browser. So the idea there was to use Insight as a backend for CoPay and just use the browser as the user interface layer. But what we don't want is for everybody to use the same Insight server. We want everybody to run their own Insight server, so you can download it and run it on your desktop or have your own Insight server running. But then that creates a problem, which is two different users of CoPay that are on two different Insight nodes can't communicate unless there's some kind of communications infrastructure there between those Insight nodes.
Hey, Stephen, I don't know if everybody knows what Copay and Insight are. It might be worth.
Okay, yeah, Copay is, thanks for the question. So Insight is it was conceived as a stack that you can run that would interface with a full Bitcoin node and give you an open source stack that could give you an API to query the blockchain, see what's going on. It looks very much like any blockchain explorer that you might see out there when you connect to it over the web. And in fact, our first project for Insight was to take our internal fork of Bitcoin.js, clean it up, and then build a blockchain explorer with that, sort of as a forcing function to make sure we had sufficient capability there that it was worth releasing. And so Insight gives you a nice block explorer, but it's also an API that you can talk to and do any kind of queries of the data in the blockchain. For example, you can find out the balance of an address. We felt like there was there were too many proprietary closed source companies out there running a proprietary stack and exposing an API. We felt like a lot of developers were just using that because it was easy. And so our objective was to create a fully open source stack with a nice API that was that people could use instead of having to talk to some company's proprietary API. So that's Insight, and then Copay is a multi-signature wallet. So you can create anything up to, I don't know how many Copayers you can create, maybe a dozen or so, but you can create a multi-signature wallet that requires 2 out of 3 signatures or 3 out of 5 signatures, and so you can have 3 out of 5 people, or you can have 5 people get together and store some funds, and then it requires 3 out of 5 people to sign it to spend those funds. So we really want to start employing that multi-signature technology to sort of eliminate Bitcoin theft. One of the things we were very, we get really tired of hearing about all the stories of Bitcoins being stolen or lost. Multi-signature can really help with that. You can also create a one-on-one transaction, so you can use Copay like a regular wallet if you want to. So that's Copay. Any questions on the inside of Copay before I move on? All right, so going back to the problem that we have is now now we're using Insight as a backend for Copay, and we allow asynchronous operations. So now you don't have to have, if you have 5 people participating in a multi-signature wallet, they don't all have to be online at the same time to create a transaction. They can do it asynchronously over, using Insight as a backend, as a kind of rendezvous. But that would require everybody to be connected to the same Insight server. And so what Foxtrot is a network that we can use with Insight that allows different Insight nodes to communicate with one another, and Copayers can be running, people using Copay can be on different Insight nodes, running their own on their desktop, or maybe they've got their own they're running in the cloud somewhere. But they can form multi-signature wallets with other Copay users that are on different Insight servers. Is that clear? I don't know if I explained that very well. Awesome. I did take a look at several other projects. I'm a big fan of CJDNS, and so they also use public keys for a location-independent address, but CJDNS also does a lot of other stuff like create an actual network device on your computer so that it's really compatible with any kind of application that you might want to use on your computer. So I think that adds a lot of other code to CJDNS, and there's a lot of stuff there that was irrelevant to the problem we were trying to solve here. And in Node.js, I felt like it was pretty simple and easy to build a lot of this stuff. Like I went and looked at the Diffie-Hellman key exchange protocol for TLS, and when you don't have to deal with 20 years of legacy cryptographic algorithms, and you don't have to deal with X509, and you don't have to deal with the PKI system, that's pretty easy to implement in Node.js. A couple afternoons of work and you're done. So I felt like because of the problem we were trying to solve and how quickly we needed to iterate on it, I felt like starting fresh with something based on Node.js would give us the best opportunity to rapidly innovate. And there are some other things that CJDNS doesn't do that I wanted to do. Also looked at Tor and I2P. And, all of those solutions do routing based upon distributed hash tables, which I don't think will work on layer 2. It kind of assumes that you have this other underlying routing platform that you can run on top of. All right, so here's a little code example. This is if you want to create a server, what you would do is you would require the Foxtrot node module, and then call the create server method, which is the same thing that the network module in Node.js uses. And then you would put a handler in there for the connect event, and when you get a connection, you can start writing to the client. So that's all the code that's required to create a server with Foxtrot. Where it says key, you would be putting in a private key. So you're creating a server with a private key, and of course there's a public key that goes along with that. Yeah, I think that's about it. Yeah, one thing I'm not showing on here is when you start up Foxtrot, it automatically, very similar to Bitcoin, goes out and tries to be very aggressive about finding peers to connect to. I'll talk more about the peer discovery in a minute. Any questions on that code? All right. On the client side, if you want to connect to a server, you would similarly create a Foxtrot instance. And then you just tell it to connect, and you give it the address. In this case, it's the public key. So you're creating a gross public key and waiting on a data event to see data being sent to you from the server. I just showed a couple other handlers here for error handler and for the error event and close event. I just showed those because they're, again, protocol compatible with the Node.js net module. So anywhere you're using normal socket code within Node.js, you could easily start using, just drop in a Foxtrot socket instead. Any questions? No? All right, so peering, this works very similar to Bitcoin itself. What you're trying to do is form a trust network of connected peers, although Bitcoin is not creating a trust network. A trustless network is what Bitcoin is trying to create. What we do is we're bootstrapping Foxtrot with very prolific peering. So we're trying to aggressively find peers and connect to them, very similar to Bitcoin. But really where this should evolve is to where peers are very deliberate about who they connect to, and they only connect to other nodes that they trust. Trust that they don't do things like denial of service attack you, or that they aren't going to abuse your connection in some way. So you really want to only be connecting to peers that you do trust. But for right now, we try to be a little more eager in bootstrapping those peer connections. So the peers, I mentioned before, each link is encrypted. So we're using elliptic curve cryptography, just like Bitcoin. Key exchange is nearly verbatim an implementation of the TLS handshake minus all the legacy algorithm support. And then, yeah, also you don't need to do the PKI X509 signature validation. We do DNS seeding very similar to Bitcoin. I've also added zero-conf connections. So if you're running on a local area network, it'll form a direct connection over the LAN to peers that are also running on the local network. And then a gossip protocol. We got it stubbed out to implement a gossip protocol very similar to the way Bitcoin tells each other about other peers. In the Foxtrot implementation, we'll need to be a little careful with the gossip protocol, because if you connect up to peers, you may not want them to gossip about you. And so you need to connect to trusted peers that don't tell other peers that you exist. All right, so a connection in Foxtrot works by creating a connection request. That connection request contains the public key of the server that you want to connect to. It also contains a nonce, which is just a random number that's generated for that connection request. And then a signature that's where the client side is creating, signing that connection request with a newly randomly generated private key. Then what you do is you take and hash that data down to a 20 byte connection ID, connection request ID. That is the SHA-256 right MD 160 that you're familiar with Bitcoin addresses. So a connection in Foxtrot is identified by this 20 byte identifier. And the connection requests are propagated through the network very similar to the way inventory requests are made in Bitcoin. So you announce this 20 byte ID, and then any peers that haven't seen the actual data, the public key and the nonce that goes with that ID, then request the details of that. And then they look to see if they've got a matching server. So you might be, that node may actually have the corresponding private key. But if not, they broadcast that hash, that 20 byte hash onto their peers. Once there's a target found somewhere in the network, they sign or they create a connect attack, which it returns to the peers that broadcast that connect request. So if I hear about a connection request, and I actually have a server that is corresponding to that public key, then I'll create a connection acknowledgement and then send it back to whoever I receive the connect request from. Then intermediate nodes, they form connections, so you might receive a connection request, you might forward that connection request on if you don't have that server. You would form it, you would send it on, and then as soon as you receive back a connect act, I now have a connection between a peer on this side and another peer on that side, and I route traffic between them. So I'll see messages that are trying to send traffic over that particular connection ID, and I'll route them. One of the important aspects of the design here is that nodes can innovate and improve routing performance independently of the protocol. So what we've implemented so far is a really dead simple approach to that routing, which is identified. I hear about a connect, I propagate that connect request, I hear an ACK back from, say, this particular peer, and then I retransmit it back from when I heard the original request come in on, and now I've formed a connection. But conceivably, you could hear about a connection request from multiple peers, and multiple peers could send back an ACK, and you could remember that information and remember things like the latency of getting that ACK back. Maybe you go ahead and set up the connection on the first one you hear about, but you remember the second, the third, and the fourth one that you heard about in case that first connection goes down. So that's just an example of ways that can be improved. And we're trying to think about the economics of this so that it really encourages, so that a node makes more money the better job they do at routing. And then the last point here, you can actually form a peering connection using a Foxtrot connection. So once you've actually plugged in and peered up with some nodes on the regular TCP/IP, let's say, you can then form a Foxtrot connection to some other node somewhere, and then use that as a peer. So you can overlay Foxtrot connections. You can use Foxtrot connections themselves as a peer. It actually gets really important when you start to think about how to implement a connection strategy that doesn't require sending a connection request to every device on planet Earth. All right, so the routing economics. So routing is where you're sitting in the middle of some connection and you're receiving data on the one end and you're forwarding it on to the destination on the other end. So the idea here is that nodes would charge money for delivering data over that connection. And if I'm a router and you send me some bytes to deliver over this connection, then what I want to do is I want to charge you a little bit more money than what my neighbor over here is charging me to forward the data. And so that way every hop in a connection path can choose whatever pricing strategy they want, and they can and every node can make a little bit of money in routing that data. So if you want to make more money with your router, what you would want to do is make better routing decisions. And I just listed some of the possibilities here. One, you can make, I mentioned you can maintain a list of backup peers and fall back on if there's a failure. So you improve the reliability of delivering data. You could potentially have multiple links on a connection, like I mentioned, and have redundancy, so you can not just send data on one connection, but also send it on multiple connections for extra guarantees about delivery. You can maintain latency stats about each peer, so that when I do get a connection request, I try the ones that are most likely to actually find a connection before I try the ones that I think are unlikely to find a connection. You can dynamically adjust pricing based on congestion. So if you're a router and you're getting more heavily congested, then you can start charging more for your routing services until that congestion eases. And that's just the beginning. I'm sure there are many more things that people could think of in terms of.
Is the pricing part of the messages that go across as the routing?
Not yet. Those are ideas.
Okay.
I said that this barely works. So.
Well, what do you think would that be?
What's that?
As kind of the messages go across, the pricing would be going around as part of the messages?
Yes. Yeah, I think the idea is that peers would have messages specific to negotiating and letting each other know how much they charge each other for the routing traffic. I mean, I used to work in the networking area, and I'm really excited to think of this in terms of how peering agreements between ISPs on the internet could potentially be changed and made better with this stuff. All right, so the economics of a connection. So a connection this is the process of sending out a connection request, finding the target of that connection request, and then actually building a path through the network. It's not feasible to flood connection requests to every single device on Earth. So one of the critical things here is to find out ways that you can sort of narrow the search path, and narrow down where you're looking to find that server. However, routers are incentivized to actually form connections. So you've got this, on the one hand, it's very expensive to kind of traverse the entire network looking for whoever the target of the connection is. But on the other hand, routers need to make money, so they want to create this connection. So as a short-term fix, before we implement payment channels and negotiation of payments, we're just going to use simple rate limiting, so that you can only do a given peer can only do a certain number of connect requests initially. And this will work while Foxtrot is a very small network, and we will actually exhaustively search the entire network of connected nodes. But as it grows, that's not going to be scalable. So again, we need to find solutions that allow you to narrow the search path, search space. So I thought of a couple things. I'm sure this is an area that requires a lot more thought, but a couple ideas I've had is creating sort of localized pools of nodes where you do an exhaustive search. So you can imagine a number of nodes that get connected to one another, and you set a flag on that peer connection that says, when one of these guys requests a connection, go ahead and send it out to these others that I've flagged, but don't send it out to the whole world, just these particular participants. So this might work on a local area network, for example. So when you use zero-conf to find those, to use MDNS and service advertisement to find those local peers on a local network, you can immediately flag those peers as being local. And then when a connection request comes along on one of those nodes, they would broadcast it to all the peers that are flagged as being local, but not the one that's being routed through your ISP, for example. So you could just flood your entire local network with these 20 byte packets trying to find another node on the network that you're trying to communicate with. And the other idea is stealth addresses. And I got to thinking about stealth addresses. Stealth addresses have an interesting property. They have something called a scan key. And a scan key lets you determine whether or not a given bit of information is intended for the person that holds that private key. So, but you can't decrypt it, right? You can't decrypt the information with that that scan key, only the person that's in possession of the actual private key can decrypt the data. So one thing you could do is you could use that to advertise the fact that your server lives somewhere. So if I'm running a server and I want to make sure everybody can connect to it economically, what I can do is, through all of my connections to the network, I can tell them about I can give them my scan key. And when they see a connection request come in, they can look at that list of scan keys and know that, you know, that I'm the one, I'm the peer that has that particular server, and not, you know, any of the dozen other connections that they have.
Does that mean like inefficient? So like, do you have to go through them iteratively, basically, and try each one?
Yeah, unless you come up with better ideas. Yeah, it would be probably expensive to test those scan keys, but if you're making a lot of money with this router, you can drop them on the internet somewhere. Maybe you can afford to do it. So stealth addresses is something from the first conception of Foxtrot that we wanted to incorporate. Right now, it's just simple elliptic curve public keys, private keys, but very soon we're going to add stealth addresses and make all the nodes know by their stealth address rather than just a simple public key. So again, I mentioned the scan key already. Oh, I should also mention, well, actually it's in here, that's the last point. So with the scan key and announcing to your peers, announcing that scan key to your peers, you can make those connections more cost effective to form because you don't have to search as much to find and make a connection. However, the expense there is privacy. So now you're telling your peers that you have the private key associated with this address. And now there are other peers on the network, and depending on how many hops away you want to advertise yourself, more and more the internet can see that, oh, this address is that server, right? Or at least that next hop in the path. So it's a trade-off, right? If you want more privacy, then do an exhaustive search of some space and don't advertise yourself, just listen. But if you want to cut down on the costs of making connections, then you can advertise yourself with a scan key.
Is there any way to like integrate like Tor, onion routing, or anything like that into it? Or?
Well, I looked at Tor and onion routing, and I felt like onion routing and distributed hash table-based routing it's not going to work on link layers. Remember, we explicitly want this to work over like Ethernet and your link to your ISP, right? So I think this would be very good. And we also wanted it to be a completely decentralized routing protocol, so you don't have to have any kind of central knowledge or tables that the hash table solutions kind of maintain. So they maintain some sort of localized knowledge of browsers on their network.
So in terms, how do you scale it, right? If it's just link layer, you connect to your ISP, you just make sure if the ISP needs to change the whole routing, I can do this.
Well, they're not going to do that tomorrow, so there's
Could it be something like a modified BGP utilizing public keys instead of IPs in terms of, you know, integration?
I mean, BGP is so badly, you know, I don't want to say broken because it actually works, but it's, I don't know, it's a complicated, convoluted, horribly, like, you know, I don't know, protocol. You know, protocol that's just kind of, I don't know, over the years been extended and modified in so many different ways. It's really a mess for ISPs. I mean, the idea here is to not have any routing tables, not have any knowledge needed by, you know, you're just really observing your peers and what's going on with your peers, as opposed to having any kind of routing tables at all. I mean, you have routing tables locally, you know that this connection is linking up this peer to that peer, but you don't have anything like BGP where you're trying to disseminate knowledge into some sort of global routing table.
So, Stephen, how does this come back to the challenge of copay and kind of offline transaction sending?
I'll get there. So I mentioned advertisements inform peers, you know, which links are likely to be to successfully yield a connection. You can also, with those advertisements, carry additional information related to metrics, like, you know, the number of hops. Like if announce your scan key to your peer, and then they turn around and then propagate that to their peers, then you could know, for this scan key, it goes through that peer, but it's 3 or 4 hops away. And again, that you have to think about privacy, and the reason you only want to connect to nodes that you trust is that you're placing a certain amount of trust for those peer connections, not to divulge too much more information than you want to be divulged. All right, so applications, here's where we're coming back to that. So multi-sig payment proposals, that's in CoPay. So in CoPay, if I want to create a multi-signature transaction, so I've got this, 2 of 3 multi-signature wallets. So I've got 3 people participating. You need 2 signatures on a transaction for it to be a valid transaction. So you need to create, if you want to spend some money on that wallet, one of those 3 people needs to create the initial transaction that does the spend. And then and this is what we call a transaction proposal, and then they need to distribute that to one of the other 2 participants for them to also put their signature on it. When this was WebRTC based and you were going browser to browser, you had to do that sort of synchronously while everyone was online. So it was decentralized, but it required this synchronous communication. When we moved to Insight, we fixed the problem of having everybody have to be online at the same time to sign these, because there's Insight maintains these transaction proposals for you so that you can create the proposal, disconnect, somebody else can connect, and then sign it. But without something like Foxtrot to be able to connect and decentralize Foxtrot or Insight nodes, everybody has to be connected to the same. Everybody in the given wallet would have to be connected to the same Insight. So that's how it's going.
Not knowing really much about Insight, so does Insight just keep a pool of those kind of like pending transactions?
Yeah, it's working. It works kind of like a mailbox. So you kind of drop these proposals into this, history of actions in this mailbox, one of which would be create a transaction proposal. And when somebody else connects, it syncs up and gets everything that happened since the last time connected. Other applications, if you wanted to negotiate payment channels, if you wanted to coordinate escrow payments. I mentioned Coin Shuffle because I think they were looking for some way to do this kind of thing. And then also, this could be an alternative to TCP/IP. So it runs today on top of TCP, but there's no reason it couldn't be made to run directly on Ethernet and not use IP at all.
Hold on a second. Did you just say that's an alternative to TCP/IP?
Yeah.
Wow.
Thank you. All right. No big deal. No big deal.
Well, okay, so there's a lot that has to happen for that actually. It's not ready. Remember, I said it barely works.
So what do you think of Namecoin integration?
I like it. We'll do something like that. Using Namecoin to, these self addresses are really long, so you'll need some kind of payment service.
What's your time frame
For what?
to make it work?
Well, it works.
How it works.
It just doesn't have stealth addresses. It doesn't have payment channels integrated yet.
How about time to incentivize mesh networks?
What's that?
How about how long until incentivized mesh networks?
Well, I don't know. That depends on, we're going to focus on CoPay for right now, but you could, for it to become an alternative to TCP/IP, you would probably want to approach that problem in a completely opposite way that they tried to roll out IPv6.
Yes.
You would want to start small and at the edges. Wireless mesh nets would be a good application of it. You could start to add support for Foxtrot directly in routers, so the WRT open source routers that are out there. You could add support directly for this running directly over Ethernet links. After a sufficient level of adoption, ISPs are going to see that, I've got all these endpoints now that are bouncing traffic across my network multiple times because they're all routing stuff between them. The ISP could then recognize that, hey, if I start running this protocol directly, now all of a sudden all of that bouncing back and forth can be eliminated, and I save bandwidth. So that would be the way I would approach ISP adoption.
Well,
And then sell them on the idea that this can solve their peering agreement problems.
would that also, I think you're suggesting too, as a monetary incentive?
Yeah, I mean, the whole idea is I can create a router and just drop it somewhere, and it's like a coin-operated machine, right? It just starts making money, right? And that, I mean, that could totally change the economics of how the internet works today.
So Stephen, regarding the copay, asynchronous communication, one of the problems you outlined was not communicating with nodes that are offline. So is there like a rebroadcast or something that's a part of this?
Well, that's part of Insight. So Foxtrot is not, I mean, it's purely about communications. There's no storage or anything like that. So think of it just as a replacement for sockets for connecting between nodes. It's not, the storage and the asynchronous part of that happens because Insight itself has, remembers what's going on in a wallet, and when another node or another copay client connects, then it can replay those. And Foxtrot, the way that works is, there can be, let's say you have 3 different people all running their own Insight node, then one of them creates the wallet, and so on the Insight, it's got that wallet creation, and then they send an invitation over Foxtrot to the other Insight nodes to invite the other participants in. Once they connect, they replicate from the first Insight, they replicate that data over to their local Insight. And as Insight nodes can stay in sync with one another that way. Did that answer the question?
But does that mean the Insight nodes are always online?
What's that?
The Insight nodes are always online.
Inside.
They can be, they don't have to be, but they can be.
But if they are not, then what is that?
Well, because you'll be connected to an Insight node when you create, like, let's say, a transaction proposal. That'll be stored on that Insight node. And then, I guess if somebody else later comes along, that Insight node has to be up and running for them to get that, to see that payment.
Like, would an Insight node in that scenario be synonymous with a merchant? Or like,
No.
would a merchant be running their own? And I'm still trying to figure out, like, who runs the different Insight nodes to kind of, like, handle these transactions.
Well, I would love to have the Insight node just run by everybody, and everybody run their own Insight node, or at least host one online.
Well, how do you know, so it's like whenever you're trying to create that transaction, like who to connect with and like how
Well,
do you
when you're running an Insight node, you would go to a URL there for your Insight node that would be running copay. And that would download copay to your browser, and copay would be running in your browser, and then communicating back to that Insight node. It's kind of, implicit in where you go to run copay that you're connected to that Insight node. There are a lot of other scenarios for advanced payment types where you need to have like an agent in the cloud validating things, observing things that are happening on the network. So we have a lot of debates internally about, to what degree will individuals, run their own trusted software in the cloud. It's still kind of an open question, I think. I wouldn't expect the average person to set up their own Insight node, right? But maybe we could convince, everybody that's, to at least use an Insight server that one of their friends or family run, right?
So you're presenting some technology that's satisfying the edge that you have internally. On the other side, you've got this sort of strategic vision that's much like somebody else's business plan. And what should we think about all of this?
I mean, in what context?
Well, when we walk away from the session tonight, is it, you're moving in this direction, or you want people to start thinking about these possibilities, or
Well, I
what's
think
the plan of action?
what's our business plan? I mean, there
Well,
are.
And write code. Fork and write code.
Yeah.
I mean, is that the pitch?
Gotta get it work first.
Well, I'm not making a pitch here. I'm a pitch for Foxtrot.
This sounds really interesting.
Yeah.
Just wondering.
Well, what I can tell you is the Foxtrot is going to be an integral part of what we do going forward, and will be well maintained and used for a lot of other things beyond just what we're talking about with GoPay.
So we should think about Bitpay differently, or?
I don't know. How do you think about Bitpay now. I will say that this is just one of the things that we're working on at Bitpay. When we're thinking about how we go forward in the future, we're thinking about how do we solve things like, I don't know, escrow payments, how do we do instant transactions on the Bitcoin network, how do we do decentralized databases. These all play into, they're our future. We're not going to be able to do this stuff without innovation in those areas. We're not going to be able to bring the kind of products that we have planned to market without doing these kind of innovations. So it's very key to what we do. I'll answer your question in a second. A simple example is we're building something that allows our accounting system at Bitpay to be secured by the Bitcoin network. And that's really key for us because that means, we kind of have this assumption that our servers at any moment in time will get compromised. And by securing our accounting system with the Bitcoin network, we can make that assumption and know that if anybody breaks into any one of our servers and starts messing around with numbers or trying to, the rest of the servers just ignore it, right? Because they can independently, trustlessly verify the history of our accounting system.
So this is sort of a really great innovation on top of like CJDNS and I2P. I was curious about what your thoughts were about the implications for the certificate authority security model that OpenSSL does.
Yeah. So I don't like the current PKI system. I really don't like, and JJ can attest to the horror that is X509. If you have a naming system like Namecoin, and you're mapping, and you're using Namecoin to map a name to an address, then when I go on the client side of these examples and create a connection to that name, then I've got a trustless verification that name maps to a certain address. And when I make that Foxtrot connection, the only person that has the private key that can allow that connection to be established is the person who matches that address. So you eliminate the possibility of any kind of man-in-the-middle attack in that scenario. So that's how I would solve the server side and authentic. So you as a client connecting to somebody else immediately know who you're connecting to because you have a trustless name point system. And you know that the only person that can respond to you is the person that has that private key. So you solved it in that direction. The other side of that is how does the server verify the identity of the client that's connecting? And that again, a name can be delivered or a public key can be delivered after you set up, an encrypted connection end to end with randomly generated keys so that you have forward secrecy. After that, you can then identify yourself with the server, and the server can verify, with the name point system, who that client is and whether you wish to talk to them or not. Does that make sense?
Yeah, thank you.
So I think it'd be better than the current system. And no more paying for those silly certificates.
We're forgetting the people.
Yeah, right. So here's a quick to-do list. Use stealth addresses. Add TCP-like delivery guarantee. So right now, Foxtrot runs on top of TCP/IP for the peer connections. But if you've got a node there that's doing routing, just because somebody sends you data on one side and you're expected to turn around and deliver it on the other side doesn't mean that you actually do, or that you deliver it in the same order, or that you don't deliver it to multiple peers that then end up arriving at the same destination node. So while the peer links have TCP guarantees, you're not really on an end-to-end basis, you're not really providing all the TCP like delivery guarantees. So that needs to be added. Right now, we're kind of just ignoring that little fact for the moment, mainly because we don't have a very sophisticated router in place. The next thing is move to UDP for peer links. So if we add TCP-like delivery guarantees end-to-end, then we can make the peer links run actually on UDP instead of TCP. And then we can actually have we can send data over a connection without and not request those TCP guarantees. So we would have the equivalent of TCP versus UDP-like delivery end-to-end on the Foxtrot network. Incorporate data channels. Talked about that one already. Multicast, I've got some ideas about how you would do multicast on this network. I think it would be pretty elegant. Service discovery, the reason I put multicast and service discovery on here was we implemented MDNS and service discovery from the ZeroConf. I don't know how many of you are familiar with ZeroConf, but this is how two nodes running on the same LAN can find each other. What they do is a local multicast, and it's called the multicast DNS, MDNS, and then they advertise services over that, and then so the nodes can find each other. But it would be nice to be able to do multicast and service discovery actually on Foxtrot instead of outside Foxtrot. We need to implement peer reconnections. So this is when a peer gets dropped. You add that peer. You try to reconnect to that peer. The gossip protocol that I mentioned. This is stuff that Bitcoin has. It should be fairly straightforward. And then just general robustification. We've done some of that as we've needed to use it for insight, just little edge conditions about like when one link in the middle of the path gets broken, am I generating the right events so that my code can see that this link is now disconnected. And that's it. I can give it a demo here.
Wait, there's more?
What's that?
There's more?
I can give you a demo.
Sure. Yeah.
We'll take your demo.
Any questions before I get into it?
Yeah, I have a question
Yeah.
about Copay. Is it usable if I was to use it today? I can use it?
Yeah, but we have a giant caveat saying do not trust any of your Bitcoins with it. So.
Okay,
Yeah, it's useful.
cool.
Usable test. Let me see if I can.
Investment?
Yeah, try it out on testnet.
Oh,
Use it on the real mainnet.
cool.
Bigger. Actually, here you can see some of the messages that are on it. So you've got typical thing like version acknowledgement. That's very much like the way Bitcoin works. Connect, that's where you're sending the connection ID. Get connect info is where a peer requests to get the connection info for a previous connect request. Connect info is actually sending that connection info, so which address, which not, so, your signature. The connect acknowledgement, a message to indicate that you've got a connection. Send destination and send origin. These connections have sort of a direction to them. So you remember which side was making the initial connection request and which side is the sort of destination of that connection request. So that's why you have two different messages, send destination and send origin. And then end destination and end origin when you want to end the socket connection. That's it. That's basically it. Demo. So here's, we made a little chat server. So I run a chat daemon. And so what this is telling me is, number one, that it's connected to this host that we're running. This is a host that we're running at bitpaylab.com. This is running Foxtrot. So this is the DNS discovery. But it's telling me that it started a chat server listening on this public key. This is just a randomly generated key pair, and it starts a chat server. It tells me it's listening on that, so I'm going to copy that. And then I go over here and start a chat server. And my name. So it takes a dash in, so I'll do that. I'm going to show you up here. So you can, there are a few things you can specify here on the command line if you want to be very specific about who you peer with. But I'm not. I'm just going to allow it to use MDNS and find peers automatically. So I'll give it my nickname and sort of So I'm specifying, I'm running the chat client, it's going to connect to that server. And so here we see that we also connected to that peer that was running in the cloud, but we also connected to this peer that's running globally. And now it says that we're connected to the chat server. So if I type a message here, you see it pop up over here. Now this connection is kind of not interesting because it's just a direct connection running on a local machine, but this would work, you know, if anybody else ran this on the same local area network, they could jump in and if they copy that public key.
So does that mean we don't need PubNub anymore?
I don't know.
We don't need IRC anymore?
I'm sure IRC is not going to die. So now what you're seeing is multiple hosts here joining, or multiple peers getting formed. I'm not sure where that disconnect is all about. So they're on the other consoles. If you're on the server, you can also type. And you see that pop up as the operator. So just a simple chat app using Foxtrot. All right, next. Yep.
What electrical curve, which family of curves did you
The same one's good.
Okay.
I figured if, or, you know, we figured if, and this is like stuff from Bitcore, so all of this, I should say, Foxtrot, all the cryptography and everything is using Bitcore. But, I mean, we all kind of have the opinion that, you know, life is going to be pretty bad if it happens broken, so we'll have a lot more things to worry about than whether Foxtrot will work.
Yeah, two questions. First is, who do you see as the first use case for this? Kind of like talking with Paul was saying, like, tomorrow people started adopting it. How do you see like multiple uses for it? And number two, how is this different than IPFS and file point from London?
I'm sorry, what was that last one?
How is this much different than IPFS and file point from participant?
I didn't quite understand that.
Do you guys know what IPFS is and file point?
I don't.
It's a Y Combinator company that launched something similar.
Okay.
So anyways, who do you see like commercially using this?
Us for, you know, coordinating, you know, payments on Copay.
So like where do you extract value from this data? Like how does this solve like a need for like businesses?
Oh, you know, I mean, if you wanted to make money with this, then build a router and get people using it, and then, you know, add payment channels to it and start charging money for that product service. I mean, if you wanted to directly monetize a router running this. You know, we have this need for coordinating more complex contracts comes up over and over and over again. So we need something like this to be able to coordinate those contracts and do it in a secure, privacy protecting manner. By the way, you know, we've thought a lot about, you know, how is this relative to like, you know, something like BitMessage. And I would say that, you know, BitMessage is, if you want absolute privacy in communications, something like BitMessage is what you would want to use. Foxtrot will give you reasonable privacy, but not absolute. Like you compromise that privacy to the degree that you need to be more economically effective at, or economically efficient at forming connection with the network. And I think you could improve BitMessage even a little bit more in other ways. Like instead of using proof of work, you could use Bitcoin directly to pay for messages to go on something like BitMessage.
Do you expect when Bitpay starts using Foxtrot, the routers will be open to the public to use?
I mean, it's open now.
I mean, like your actual hosted like router, would that be something that because it kind of seems like a chicken and egg problem. Like I can't really use it because there aren't routers on the internet that I can connect to.
Yeah, I mean that 23.253 address is out there, and it's baked into the source code, so it'll automatically try to connect
So I
to
could
that.
use that
Now, you can very trivially denial of service that right now. You know, when we add things like rate limiting to it, and,
But your anticipation is like if you have a service that starts growing and you add your rate limiting and stuff to it, then you'll probably leave those open for other developers to use for them.
yeah, absolutely. I mean, it's kind of like seed nodes for the Bitcoin network. Also, one other aspect of this is I'm of the belief that we need to start using the Bitcoin mesh network purely for moving or communicating transactions from originator to miner instead of relying on that network for communicating transactions from sender to recipient. And the reason for that is that if we're ever going to form like a market-based approach to transaction fees, then nodes on the Bitcoin network need to be able to decide that they don't want to forward a transaction because it's not profitable, nobody will pay for it, or what have you. But if you do that today, you could impair the function of that mesh network for delivering transactions from sender to recipient. So having something like Foxtrot gives you the potential to move those transactions directly from sender to recipient over this network and maintain privacy while doing it. The payment protocol does that to a degree today as well. You know, it's more server client oriented than you know, than would be ideal. But at least with the payment protocol, you can communicate a payment message or a payment directly from the sender to the recipient instead of moving it over to Bitcoin network. Also, the Bitcoin network has something called service bits, and there's a possibility that you could enable another service on the Bitcoin network that was Foxtrot, or do the inverse.
Does this have the potential to get rid of the need for dynamic IP addressing?
Yeah, in the sense that it has the potential to get rid of the need for IP addresses. I mean, it's kind of fun. I don't expect this to take off or anything like that, in a huge way that it replaces TCP/IP, but it is fun to think about, and something like this probably will take off. And if you get rid of IP addresses, it's funny to think about how much money and time and energy was spent on IPv6, and something like this could just make it completely irrelevant. All of that money that's been spent trying to roll out IPv6 over the last 20 years, 15 years, whatever. It's completely wasted.
I don't know if there's any legal restrictions on actually starting your ISP, even if it's
No, I can't imagine what.
just one.
Paying for bandwidth with Bitcoin. Yeah.
You made a side comment about the securing the accounting servers with Bitcoin network. Could you elaborate on that?
I mean, we're working on something that allows you to create a decentralized database that's secured by the Bitcoin network itself. That's really important because we want the full power of the Bitcoin network securing that database, not just, well, with side chains, for example, side chains are great, by the way, I love the concept, but you're taking value out of the Bitcoin network, putting it in the side chain. And the idea behind that is, number one, you don't inflate the currency, but also you can experiment with other consensus protocols. And there are a lot of cases where you would want different consensus protocols. And I can think of decentralized exchanges where I need to announce orders and I need to have a localized consensus, not a global consensus, but a localized consensus that happens within milliseconds. Because orders and trading happens on that kind of a scale. You can't wait 10 minutes for everybody to figure out whether their trade is executed or not. So side chains are great for that. But there's also this other class of databases that are where you would want the full power of the Bitcoin network to secure it. And what we're doing there is making it so that I can create a database or define a database, define the transactions in that database. I have a token with each kind of transaction. Namecoin's got one token for the whole system. It got one part of it right where it had a very fixed exchange rate between the ability to register a name and the token. But there are all kinds of other transactions that occur in that database that they don't have their own tokens for. So, for example, renewing a name, updating a name registration, transferring ownership of a name. All of those should have their own coins or their own tokens associated with them. And that way, there becomes an independent market for each kind of transaction in this database. And then when you talk about the blocks, instead of having your own, blockchain that has independent blocks, independent from Bitcoin, instead create the blocks and then define them by creating a transaction in the Bitcoin network. And we've come up with like a bidding process where people would bid to actually create transactions. They bid by increasing the transaction fee of the Bitcoin transaction that defines the block of your chain DB. Chain DB is what we call it. That's what we're going to use for our accounting system, but it could be used for an endpoint-like system. There's tons of applications for it, actually. And the really cool thing about thinking about that is now once you've got these databases sort of being embedded in the blockchain history, the Bitcoin blockchain history, now I've got proof of the history of the transactions of this other database. And I like to think about like, what's the web archive or the internet archive where they snapshot all the websites and they keep track of them. Well, imagine if they did that with the chain DB and put those timestamps in the blockchain. Now all of a sudden you have incontrovertible proof that something existed at a certain point in the past. I mean, they'll tell you, I think, that there have been instances where different media outlets have actually revised history. But you've got to believe the Internet Archive today. Now the Internet Archive, if they're timestamping everything in the history of the blockchain, you don't have to trust the Internet Archive. You can go and verify that that history actually happened. That's really cool, and I think that's sort of like a digital, record of human history. And it first became clear when I heard Julian Assange actually in an interview talking. I don't know if any of y'all heard this, but he mentioned 1984, George Orwell, and the quote in that book where, he who controls the past controls the future, and he who controls the present controls the past because they can rewrite history. Well, you can't do that anymore. And I think that's pretty cool.
I see kind of the Foxtrot foundation as a way that networks can economically route information between each other. Do you see any application for taking that concept out of just strictly information systems, communication systems, into something realms of like either transportation or energy, where basically right now we have really, really dumb systems that try and monetize that process, but they're not adaptive, they're not, instantaneous. And I see Foxtrot being able to do that, autonomously.
Mm-hmm.
Do you see application for that, or?
No, but I'm going to think about that one. I mean, I haven't thought about it. I've just really thought about it in the context of routing on the internet. But that's an interesting idea. I think, I take Uber all the time. They have that demand and pricing, so I kind of think about
like one of the big challenges moving forward in the energy space is distributed generation. So everybody's putting PV on their houses, but in order to push that power on the grid to different places, there's going to be a big challenge to transact with that economically.
Yeah.
Because I see Foxtrot as a solution for that.
It's kind of like routing energy.
Yeah.
Yeah, I mean, a lot of people talk about the use of payment channels not just for bandwidth metering, but also electricity metering, gas metering, all kinds of metering type applications. That's cool.
Can you talk more about how ChainDB works?
Well, which part of it do you want?
Just here, I'm hearing you talk about it.
Yeah, so I mentioned that you create blocks in ChainDB, and those get embedded in the Bitcoin blockchain by a transaction that references the hash of that block in ChainDB. So the idea there is you have these tokens, and you would create whatever rules for those tokens to come into existence in the ChainDB blocks, and those tokens would, if the database is used by people, it would have a market value because people would want to create transactions in that database. So what you do to actually create the Bitcoin transaction that defines the block in ChainDB is you create a transaction and then you attach a fee that gets it mined. And then the idea there is that people will see these tokens that they can obtain in the ChainDB, and that they would want to create the transaction and attach a fee to it because the tokens are worth more than the fee. Now the problem, so there's this bidding thing, so multiple people can do that. The problem is you don't want the losers in that bidding war to lose their Bitcoins. So they want to be able to bid and bid up that fee, but if they're the loser, they don't want to lose their Bitcoins. So the idea that we had on that was to actually embed a private key in each of the ChainDB blocks, and that private key would be the key that you needed to spend an output of the Bitcoin transaction that defined the block. So you'd have one output in the Bitcoin transaction that had to be used as an input in the next Bitcoin transaction that defines the next block in your ChainDB. And that way everybody can use that same input and build new transactions with higher and higher fees in a bidding process until somebody gets embedded in a block. And the ones that, because these bids are deliberately conflicting transactions, you can never have more than one of them mined in a block, right? And you'd have to change, like, if you wanted to do this over the current mesh network, you'd have to change some of the transaction propagation rules on the mesh network, but there's nothing about the Bitcoin protocol itself. And when I say the Bitcoin protocol, I mean the actual blockchain, not the peer-to-peer mesh network. There's nothing about the Bitcoin protocol that would prevent something like that from working. So you have this bidding process, and people look at the value of the tokens that they get awarded in a ChainDB, and then bid up the value of the transaction that defines that block. And that's nice too, because you get automatic. That's how miners on the Bitcoin network are automatically getting rewarded for all these ChainDBs out there that are getting timestamped in the blockchain by virtue of these fees. You don't have to do anything like merge mining and such.
One last question. Corrado. Yes.
I was wondering, I mean, you mentioned several times that you envision something like this scaling to replace TCP/IP or similar systems, and not specifically this system. So which parts of this system would you say are so novel as to replace TCP/IP, and do you think could scale to the scale that we see IP packets flowing today, like the tableless routing or the encrypted connections between routers, or paying for bandwidth per bandwidth?
Well, the tableless routing scales because you don't have any centralized database that you have to distribute everywhere. So you make localized decisions at each router. The hard part is that initial connection. Once you have that initial connection, you have a path to the network, and everything is fine because you're routing bytes based on who will pay you to route those bytes, and you're making money, and the routers are incentivized to do it. But it's that initial connection that's sort of the challenge. And I think really the only what you have to think about is ways that you can narrow down the scope of the search, and that's why I mentioned the scan keys. So with scan keys, you can give your peers a way to know what private keys, or what connection requests match a private key that you have. And so you can distribute the scan keys to different peers, propagate them through the network as far as you would like, and carry along with that advertisement information about metrics and stuff like that.
And how do you envision tableless routing scaling to very large scales like you'd see on a backbone of the internet, right? I mean, with this tableless routing that you're proposing, it seems you're essentially managing a per connection state each time. I mean, you don't have a central table locally, but you have a per connection that's flowing through you table that you're maintaining. How do you envision that kind of? Well, I mean, not on the scale of terabit per second BGP and central IP exchange kind of routers.
I don't understand.
Well, I mean,
there are routers out there.
AMSIX certainly doesn't maintain any kind of state per connection. It operates purely on individual IP packets and looks it up in the table that it has. And it seems you're proposing more to keep track of every connection flowing through a given router at the router.
Well, I mean, it's not that different from carrying along with that connection, the source and destination IPs, which taken together with the ports is kind of the same thing.
If you're passing along the routing information per router so that it can look it up, sure. This is getting back to there's a lot of protocols kind of before TCP/IP that did the same kind of thing where you negotiate a path before you start a connection and then you maintain the path of the connection. And it didn't scale because there was too much state, and it became much simpler, especially when you're looking at the kind of traffic that we see today, where you don't keep track of that state. Like you have no non-persistent state.
Yeah, I don't know, maybe we'll scale. No, that's good. That's a good point. Yeah, it is very stateful. So you do have those connection paths, but I don't know. That's something to think about. Maybe the decisions today would be different. Maybe what would scale.
Yeah. Well,
20 years ago.
Scales at different scales for different purposes, right?
Yeah.
Scale.
All right. Can we get the man?